With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let us have a look at the question first of all. So the question is of paragraph type. So let us see what the paragraph is all about. So paramagnetism is a property due to the presence of unpaired electrons. In case of transition metals, as they contain unpaired electrons in n-1 d-orbitals, most of the transition metal ions and their compounds are paramagnetic. So in this paragraph, they are talking about the paramagnetism property that is shown by most of the transition metal ions and their compounds because of the unpaired electrons that they have in n-1 d orbitals. Now they are also adding that paramagnetism increases with the increase in the number of unpaired electrons that we can see just by looking at this formula of magnetic moment. So mu is equal to under root n into n plus 2 Bohr magneton, where n is the number of unpaired electrons, right? Now, just by looking at this formula itself, we can say that if n will increase, then magnetic moment will increase, and eventually the paramagnetic property of the ion or the compound will increase, right? Now, they are saying that similarly, the color of the compounds of transition metals may be attributed to the presence of incomplete n-1 d subshell, right? So in this paragraph, moreover, they are talking about color of the compound that is shown by transition metals, right? And that is, or that can be attributed by the presence of incomplete n-1 d subshell, right? Now, when an electron from a lower energy of d orbitals is excited to a higher energy in d orbitals, the energy of excitation corresponds to the frequency of light absorbed, right? So what happens that when an electron is unpaired and that is in d orbital, then on attack of a ligand, right, according to crystal field splitting theory, d orbital splits into two energy levels, right? There is a lower energy level that is called as T2G, and there is a high energy level that is called as EG, right? Now that particular electron that is unpaired sometimes takes energy from visible radiation and get itself promoted and excited to a higher energy level that is EG. After some time it returns emitting or radiating that energy, right, which falls in the visible region, right? Now the color observed corresponds to the complementary color of the light that is observed. Now they are also telling us that the frequency of the light absorbed is determined by the nature of the ligand. Now this is very important, that the frequency of the light that is absorbed, and that is determined by the nature of the ligand, right? Now, in this paragraph, they are also asking us a question based on the information that they have given us, that identify the correct statement, right? And here we have been provided with 3 statements and 4 options total we have, and we need to find out that whether these statements are correct or not. So let us take them one by one and try and find out that whether they are correct or not. So the first one says that Mn plus 2 or 2 plus has the highest paramagnetism amongst the bivalent cation of the first transition series, right? So they are telling us that to verify that Mn plus 2 has the highest paramagnetism shown by any bivalent cation in the first 3D transition series. Now to verify that, we will have to write down the electronic configuration of all the bivalent cations of 3D series, right? So at first we have scandium, right? So scandium plus 2, then we have titanium, right, plus 2. So along with it, I'll just write down the electronic configuration also. So scandium plus 2 has the electronic configuration of 3D1 and 4s0. Titanium plus 2 has 3D2 and 4s0. Similarly, moving on to the next one, we have vanadium, right? So vanadium plus 2 has the configuration of 3d3 and 4s0. Similarly, we have the next one, that is chromium. So chromium plus 2 has the configuration of 3d4 and 4s0. Moving on, we have Mn plus 2. We again have Fe plus 2. So let me just write down all the bivalent ions first of all, and then we can easily write down all the electronic configuration, right? So Co plus 2, then we have nickel plus 2, Cu plus 2, and last we have our zinc ion, right? Zinc plus 2. Now Mn plus 2 has 3d5 4s0. Iron has 3d6 and 4s0. Similarly, we have 3d7 4s0, and nickel has 3d8 4s0. Copper has 3d9 4s0, and last we have 3d10, that is complete, and 4s0. Right. Now, talking about the unpaired electrons, the first one has one electron in its d subshell and only one electron. S orbital is empty, so it has one unpaired electron, right? So here I'll be writing unpaired electrons, right? So it has 1, it has 2, right? Vanadium has 3, right? It is pretty much evident just by looking at the electronic configuration itself, right? So 4, and then we have 5, then we have 6, 7, I'm sorry, no, it's 5, then we have 4, right? Then we have 3, then we have 2, and then we have 1, and then at last we have 0, right? So this is how we can write down the all unpaired electrons that are in the subshells of all these ions. Now, as we can see here that manganese here has the highest unpaired electron in its subshell, right? Highest unpaired electrons means it will show, so N is highest here, right, which is equal to 5. So just because it has the highest number of unpaired electrons in its d subshell, which means that it is going to show highest magnetic moment to us, right? So magnetic moment is equal to n under root n into n plus 2, right? So this will be also highest in this case. Okay, so this is how we can say that the first statement that have been given here is the correct one, right? Now, just not the first one, but also the third one. So third one is that in 3D series, the paramagnetic character first increase to maximum and then start decreasing. So as you can see here, the unpaired electron first increases till manganese and then it decreases, right? So this statement is also correct, because as the number of unpaired electrons are increasing, the magnetic moment will increase, and hence we can say eventually the paramagnetic character will also increase. So the third statement is also correct. Now moving on to the second one, which says that the colored ions or compounds of transition elements are due to dd transition and charge transfer spectrum. Now this is also true. As they have unpaired electrons, right? So unpaired electrons means they will show dd transition, right? That we have already discussed in our paragraph. And because of this dd transition, they are going to show color, right? So we are going to get, colored ions or compounds. And also what happens here, that some of the ions do not have any electron left in its, d subshell, n-1 d subshell. So those compounds or those ions also show color because of LMCT. So this is ligand to metal charge transfer, right? So just because of the charge transfer, it also, those ions such as permanganate ion or chromate or dichromate ions, so these ions also show color, right? So having said that, now I can say that the second statement is also the correct one, right? The last one is false, and this is how we can understand and solve this question. I hope this is clear to you. Thank you.
For class 6 to 12, ITG and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.